हेलो विद्यार्थी मित्रों, चैप्टर 1 लेक्चर नंबर 5. See, in 11th standard we already seen some basic concept of function. Let us recall definition of function. A is non-empty set, B is non-empty set. If there exists some relation or correspondence or some rule that associates every member of set A to unique member of set B, then such a relation or correspondence or such a rule is called function from A to B. N is denoted by F from A to B. A is called domain and B is called codomain. Here our aim is to discuss types of function. First of all, let us put that knot. F from A to B is function, then A is known as domain, B is known as codomain. And what is range of F? It is a set of all elements of codomain for which X is in A. X is called pre-image. For example, let us consider F from R to R, f of x is equal to x, then this x is known as pre-image and x square is called image. Image always goes in codomain, pre-image always comes from domain. Now see, let us see for this example f from R to R. I am taking f of x is equal to x square. Now let us consider f from R to R, f of x is equal to x. Here f of 1 is 1. F of minus 1 is also 1. Here you can see that two elements of domain, these are the distinct elements. Even though images are same, here f of 1 1, f of minus 1 likewise. So here for 1 not equal to minus 1 implies f of 1 not equal to f of minus 1. This means this one is a distinct pair of points from domain, have a distinct images. Such a function is called 1 1 function. So let us define 1 1 function. 1 1 function, or in other words, injective function. If for function f from A to B, for all x1, x2 belongs to A, x1 not equal to x2 implies fx1 not equal to fx2. Distinct pair of points from domain have a distinct images. And then f from A to B is called 1 1 function. is called 1 function. In other words, let us see. We already seen in terms of logic, if P implies Q is a mathematical statement, what is contrapositive? Contrapositive of this statement is negation. Q implies negation P. Now what is contrapositive of this statement? In other words, or if for x1, x2 belongs to A, f of x1 is equal to f of x2 implies x1 is equal to x2. Negation of f of x1 not equal to f of x2 is f of x1 is equal to f of x2. And what is negation of, for all there is sum. For some x1, x2 belongs to A, x1 is equal to x2. Then f is called, or f from A to B, f from A to B is called 1 function. Clear? Or injective function. Next, onto function. Next type of function is onto function. Surjective function. Other name is this one. Now see here. For example, let us consider f from n to n. F of n is equal to n. F from n to n. F of n is equal to n plus 1. So, f of 1 is equal to 1. F of 2 is equal to 2. Likewise, what is range of f? F of n belongs to n. Yes or no? But f of n is equal to n. N such that n belongs to n is nothing but n. So range of f is here n, and that is our codomain. Yes or no? Here what we get here? Here range of f is equal to f of n such that n belongs to n. What is f of n? N plus 1, n belongs to n. So that comes out 2, 3, 4 likewise. 2, 3, 4 likewise. And that is all set of natural number except 1. This one is range of f. Now see here. Here range of f is subset of n. See, n minus 1 is subset of n. Clear? So range of f is always subset of codomain. But if range of function f is same as to codomain, then that function is called onto function. So let us see definition. If for function f from A to B, range of f is equal to codomain, then f from A to B is called onto function. Now see, range of f and codomain both are sets. One way result is true. Range of is always subset of codomain. But when these two are equal, if both are subset of each other, that means if B is subset of range of f, then function is onto. Now to show that B is subset of range of f is set of images for the elements of domain. So every element of B should be in range of F. That means every element of B should be expressed of this form. And then we can say that onto function. In other words, or if for every Y belongs to B, there exists X belongs to A such that f of x is equal to y, such that f of x is equal to y. Then f from A to B is called onto function or surjective function or surjective function. Clear? Now, next definition, bijective function. If f from A to B is 1, 1 and onto, then f from A to B is called bijective function. Clear? Now, dear friends, let us see how we use these two definitions for problems to solve examples. Here, f from A to B function is given to us. We already seen two ways. For all x1, x2 belongs to A, x1 not equal to x2 implies fx1 not equal to fx2. We are going to use this definition to show function f is not 1, 1. આપણે આ ડેફિનેશનનો ક્યારે યુઝ કરશું? ટુ શો ધેટ ફંક્શન ઇઝ નોટ 1, 1 and to show that function is 1, 1 for some. For x1, x2 belongs to A, take f of x1 is equal to f of x2 and prove that x1 is equal to x2. We are going to use this definition to show function f is 1, 1. Clear? Next, f from A to B. We already seen two definitions to show that it is 1, 2 function. Range of f is equal to B, then function is 1, 2 function. And for other definition is for every y belongs to B, there exists x belongs to A such that f of x is equal to y. Here we are going to use this definition to show function f is not onto, and we are going to use this definition to show function f is onto function. Clear? One more thing, remaining two definitions. If f from A to B is not 1, 1, then it is said to be minimum, said to be minimum. And if f from A to B is not onto, then it is said to be into function. Clear? So these are the basic concept of types of function. Let us move on exercise. Now we are able to solve exercise 1.2 NCERT, exercise 1.2, example number 1, so that the function f from R star to R star defined by f of x is equal to 1 by x is 1 when and 1 2, where R star is set of all non-zero real numbers. Clear? Is this result true? Result true if domain R star is replaced by n with codomain being same as R star. Clear? Now see, this is the question. Here we are going to answer this question. Here it is given that here R star is set of all non-zero real numbers and f is from R star to R star. F of x is equal to 1 by x. For x1, x2 belongs to R star. Here we want to show that it is 1, 1 and 1, 2. So start with this definition. F of x1 is equal to f of x2. This implies 1 by x1 is equal to 1 by x2. This implies x1 is equal to x2. So what we see? For x1, x2 belongs to R star, f of x1 is equal to f of x2 implies x1 is equal to x2, and therefore f from R star to R star is 1, 1. Clear? And second thing, we want to show that it is 1, 1 as well as 1, 2. So for all y belongs to R star, we have x is equal to something. What we want to show? F of x is equal to y. That means we want to show that 1 by x is equal to y. That means what should be x? X is equal to 1 by y. So we have a x is equal to 1 by y belongs to R star such that f of x is equal to f of 1 by y is equal to 1 over 1 by y, and that is y. So for every y belongs to B, we have x is equal to 1 by y belongs to R star such that f of x is equal to y, and therefore f from R star to R star is 1, 2, and therefore f is 1, 2 function. Clear? Next they are asking the question, if domain R star is replaced by n and codomain remains same, then what happens, that we want to see. Now f from n to R star, f of x is equal to 1 by x, that we want to see. Now see here, for x1, x2 belongs to n, let us start with f of x1 is equal to f of x2. This implies same way 1 by x1 is equal to 1 by x2, because it is a set of natural number, definitely it is positive, sorry, non-zero, positive as well as non-zero. x1 is equal to x2. So what we seen, for x1, x2 belongs to n, f of x1 is equal to f of x2 implies x1 is equal to x2, and therefore f from n to R star is 1, 1. Now for 1, 2, we have to take y belongs to R star, non-zero real number. Consider y is equal to 1 by 3 or y is equal to 3. Let us consider y is equal to 3. What we want to show? We want to show that we want to find some x belongs to n such that f of x is equal to 3. So 1 upon x is equal to 3. So x is equal to 1 by 3, that is not in n. So now for y is equal to, you can take any real number, y belongs to 3, y equal to 3 belongs to a star. We have x is equal to 1 by 3 such that f of x is equal to f of 1 by 3 is equal to 1 over 1 by 3 is equal to 3. But x is equal to 1 by 3 is not a natural number. So we can write that for some y belongs to R star, or we can say that range of f is not equal to n also, and therefore range of f is not equal to codomain R star, and therefore f from n to R star is not onto function, that means is into function. Clear? Next example, let us see, that is second example. Check the injectivity and surjectivity of the following functions. Clear? First one, f from n to n, f of x is equal to x square. Second one, f from z to z, f of x is equal to x square. Clear? Third one, f from R to R, f of x is equal to x square. Now we can see that this thing, please see here. Here f from n to n, f of x is equal to x square. Clear? So for x1, x2 belongs to n, f of x1 is equal to f of x2 implies x1 square is equal to x2 square, implies x1 is equal to x2. Why? Because x1, x2 belongs to n, it is positive natural number, so they remain same. And therefore, for x1, x2 belongs to n, f of x1 is equal to f of x2 implies x1 is equal to x2. And therefore, f from n to n is 1, 1. Now find out range of f is equal to f of x belongs to n is equal to x square, x belongs to n, that is equal to 1, 4, 9, 16, likewise, which is not equal to codomain. So what? And therefore, range of f is not equal to n. And therefore, we can say that f from n to n is not onto. Clear? Same way, please see here. Here, f from z to z, z is set of integer. And for set of integer, we can mention that here f of 1 is equal to 1 and f of minus 1 square is equal to also 1. So, distinct images have for 1 not equal to minus 1, for 1 not equal to minus 1, f of 1 is same as f of minus 1. So, for 1 not equal to minus 1, we have f of 1 not equal f of 1 equal to f of minus 1. So, distinct images have same images. Distinct elements of domain have a same images, and therefore f from z to z is not 1, 1. Clear? Is not 1, 1. Also find range of f. F of x belongs to z, that is equal to x square, x belongs to z, that includes 0 also, 0, 1, 4, 9, likewise, is not equal to codomain. Codomain is here z, and therefore range of f is not equal to codomain, and therefore f from z to z is not 1, 1. Why here 1, 1 for this case? Because x1, x2 is a positive natural number. So we get the same distinct element have a distinct images, or images are same, then x1 is equal to x2. In case of this one, positive, negative numbers are there. So 1 not equal to minus 1, 1 not equal to minus 1, even though we have f of 1 is equal to f of minus 1. So that is not 1, 1 function. Clear? Now let us see here what happens. Same way, here any you can take real number, positive, negative, square always gives us positive. Here for 1, here for 1 and minus 1 belongs to R, f of 1 is equal to 1 square is equal to 1, f of minus 1 is equal to minus 1 square, that is also 1, and therefore for 1 not equal to minus 1 we have what? F of 1 is equal to f of minus 1, and therefore f from R to R is not 1, 1. Also find out range. Also range of f is equal to f of x, x belongs to R, because here domain is set of real number, is equal to x square, x belongs to R, is nothing but non-negative real number, that is R plus union 0, and that is not equal to R. So range of f is not equal to R, and therefore f from R to R is not onto, is not surjective, is not injective, because injectivity means oneness and surjective means to check that it is 1, 2 or not. Clear? Yes. Now let us see more example. F from n to n. F from n to n. F of x is equal to x cube, and 1 minute, f from z to z. F of x is equal to x cube. We want to check that whether it is 1, 1 or not. Clear? Now see. See, for x1, x2 belongs to n, f of x1 is equal to f of x2. This implies x1 cube is equal to x2 cube. This implies x1 is equal to x2. Why? So here x1, x2 belongs to n. And therefore, what we seen? For x1, x2 belongs to n, f of x1 is equal to f of x2 implies x1 is equal to x2, and therefore f from n to n is 1, 1 or injective. Clear? Now, what is range of f? Range of f is nothing but f of x, x belongs to n, is nothing but x cube, x belongs to n, and that is equal to 1, 8, 27, likewise, but which is not equal to n. So range of f is not equal to n, is not equal to codomain, and therefore f from n to n is not onto or not surjective. Okay? Yes. Here Z to Z is given. Here for x1, x2 belongs to Z, f of x1 is equal to f of x2. Imply the x1 cube is equal to x2 cube. x1 cube is equal to x2 cube. And this implies x1 is equal to x2 because cube of two integers are same only when both integers are same. And therefore what we seen? For x1, x2 belongs to Z, f of x1 is equal to f of x2 implies x1 is equal to x2. And therefore f of Z from Z to Z is not 1, is 1 1, is 1 1. That is injective, sorry, huh? Is injective. Now find out range of f. F of x belongs to Z, x cube, x belongs to Z, that is equal to 0, plus or minus 1, plus or minus 8, plus or minus 27. Likewise, that is not equal to codomain, and therefore range of f is not equal to Z, and therefore f from Z to Z is not onto or not surjective function. Clear? Yes. Now we know that integer part function. Next example. Prove that greatest integer part function f from R to R, f of x is equal to, see, this is the notation for integer part function x, is neither one one nor onto. Clear? Where what is meaning of this one? Denotes the greatest integer not less than or equal to x. Clear? Now here we want to check that it is one-oneness and one-two-ness. Very simple question. See here, not that n less than or equal to x less than n plus 1, n belongs to Z implies integer part function is equal to n. That we know. Clear? And therefore, here first of all mention that f from R to R, f of x is equal to integer part function x. Now test this according to this one. F of 1, 1. F of 1.2 is also 1. And therefore, for 1 not equal to 1.2, we have f of 1 is equal to f of 1.2, and therefore f from R to R is not 1, 1. Also, range of f is equal to f of x belongs to R, is equal to integer of part function x belongs to R, and that is equal to 0 plus or minus 1 plus or minus 2 is equal to z, and therefore range of f is equal to z is not equal to codomain, and therefore range of f is not equal to R, and therefore f from R to R is not 1, 2 or is not surjective. I would like to put one note. If we take f from R to Z, f of x is equal to integer part function x, then f is not 1, 1, but it is 1, 2. 1, 1ness as per previous part, you can use this part to show that f is not 1, 1, same thing. But for range of f, range of f is equal to f of x belongs to R, integer part function x belongs to R, and that is nothing but 0 plus or minus 1 plus or minus 2 and so on, that is z. So range of f is equal to z, and therefore f from R to z is onto function. Clear? Yes. Now see, for next example, f from, so that is the example number 4, so that function f from R to R, f of x is equal to modulus function is neither 1, 1 nor 1, 2. Clear? How to check this thing? Very easy. Now see here, f from R to R, f of x is equal to magnitude of x. For 1 and minus 1 belongs to R, f of 1 is equal to magnitude of 1 is equal to magnitude of 1, f of minus 1 is equal to magnitude of minus 1, that is also 1. And therefore, for 1 not equal to minus 1, we have f of 1 is equal to f of minus 1. And therefore, f from R to R is not 1, 1. This function is not 1, 1. Same way, it is not 1, 2 also. Why? Now, find out range. Range of f is equal to f of x belongs to R, and that is equal to modulus of x belongs to R, is nothing but R plus union 0, is non-negative number, but which is not equal to R. So range of f is not equal to R, and therefore f from R to R is not onto function or is not surjective function. Clear? Yes. Next, example number 5. So that the signum function f from R to R given by f of x is equal to 1 if x greater than 0, 0 if x is equal to 0, minus 1 if x is less than 0, is neither 1 1 nor onto. Now see, here f from R to R is defined by, we have to take 1 only when if x is positive, 0 only when x is equal to 0, minus 1 only when x less than 0. For 1, 2 belongs to R, f of 1 is equal to 1 because 1 greater than 0. F of 2 is also 1 because 2 is greater than 0. So for 1 not equal to 2, we have f of 1 equal to f of 2, and therefore f from R to R is not 1 1. Clear? Also find out range. Range of f is equal to what? Only 3 elements, 1, 0 and minus 1. That is not equal to codomain. And therefore range of f is not equal to codomain. And therefore f from R to R is not onto function. Is not an onto function. Clear? Next, let A is equal to 1, 2, 3. Example number 6. And B is equal to 4, 5, 6, 7. And let function f is equal to 1, 4, 2, 5, 3, 6 be function from A to B, so that f is 1, 1. So here A is equal to 1, 2, 3, B is equal to 4, 5, 6, 7, and F is equal to 1, 4, 2, 5, 3, 6. Means what? That is, f of 1 is equal to 4, f of 2 is equal to 5, and f of 3 is equal to 6. Oh, 1 not equal to 2 implies f of 1 not equal to f of 2, and 2 not equal to 3 implies f of 2 not equal to f of 3. 1 not equal to 3 implies f of 1 not equal to f of 3. So we can write for all x1, x2 belongs to A, x1 not equal to x2 implies fx1 not equal to fx2. Yes or no? Yes. And therefore f from A to B is 1, 1. Here they are not asking for one-to-ness, but if we want to see that thing, then what happens? Here, what is range of f? Range of f is 4, 5, 6. 4, 5, 6 is not equal to B, because one more element is there, but that is not in range. And therefore range of f is not equal to codomain, and therefore f from A to B is not onto function. Clear? Now let us see example number 7. First part, f from R to R. F of x is equal to 3 minus 4x. Here we want to check that whether it is 1 or 1 2 or not. Bijective, justify your answer. That thing we have to check here. Example number 7, first part. But I would like to check for in general question. Prove that f of x is equal to ax plus b. A not equal to 0, comma b belongs to R is bijective function. Means is 1, 1 and on 2. Clear? If we solve this one, then you are able to solve this one also. Very easy to for you. Now see here f from R to R. F of x is equal to ax plus b. For x1, x2 belongs to R, let us consider f of x1 is equal to f of x2. This implies ax1 plus b is equal to ax2 plus b. Now b cancel. ax1 is equal to ax2. Now a is non-zero, so x1 is equal to x2. So what we seen? And therefore, for x1, x2 belongs to R, f of x1 is equal to f of x2 implies x1 is equal to x2. And therefore, f from R to R is 1, 1. Also, we want to show that f of x is equal to y. So ax plus b is equal to y. So ax is equal to y minus b. So x is equal to y minus b by a. Yes, that exists. Also for every y belongs to R, we have x is equal to y minus b by a belongs to R, such that f of x is equal to f of y minus b by a. A of y minus b by a plus b, that is equal to y minus b plus b, that is equal to y. So for every y belongs to R, we have x is equal to y minus b by a belongs to R, such that f of x is equal to y. And therefore, f from R to R is onto. and therefore F from R to R is bijective as it is 1 1 and 1 2. That we know. If function is 1 1 and 1 2, then it is bijective. Now F from R to R, seventh example, second subpart, F from R to R, f of x is equal to 1 plus x square. We want to check whether it is 1 or 1 or not. Here f of 1 is equal to 1 plus 1 square, that is 1 plus 1, that is 2. F of minus 1 is equal to 1 plus minus 1 square is equal to 1 plus 1 is equal to 2. And therefore 1 not equal to 4. Therefore, for 1 not equal to minus 1, we have f of 1 is equal to f of minus 1, and therefore f from R to R is not 1 1. Also find out range of f. F of x, x belongs to R, that is equal to 1 plus x square, x belongs to R, is only set of positive real number. Is set of real number, or is a subset of positive real number. Is a subset of positive real numbers, and which is not equal to R. So range of f is not equal to codomain, and therefore f from R to R is not 1 2, and therefore f from R to R is not bijective function. Now see, I would like to give some homework. Illustration number 7 to 14. Homework, as well as exercise 1.2, question number 15, 11 and 12. 11 and 12 for homework. Rest of thing we are going to see in a next lecture. Thank you, dear friends.